Taking a look at numbers 13 through 24, that second set of ACT prep. You've had a chance to do SAT prep, okay? We're going to do more of that as we go along as well, but we're going to counter it with some ACT prep here and to see how we did on these. So number 13 says the lead or the pitch of a screw is the distance the screw advances in a straight line when the screw is turned one complete turn. You turn it, it goes in. Or you turn it the other direction, it goes out. If a screw is 2.5 inches long and has a lead of an eighth of an inch, how many complete turns would get it all the way into a piece of wood? Answer should be letter D, 20. Letter D, 20. How many had 20 for that first one? Here's how I did it, okay? If it goes in an eighth of an inch, how many turns get it a full inch? 8, right? So if I want 1 full inch, that's 8 turns. If I want another full inch, that's 8 more turns. And I do a quarter, 4 more turns gives the extra half. That's how I did it, because that's just how my brain ticks. Technically, you could do 2.5 divided by 1/8 equals.
That's what I did.
On your calculator, of course, and that'll also get you 20, right? 2.5 inches desired divided by 1/8 of an inch every time you turn it would also give you 20, but I like to think in whole numbers, not fractions, because I hate fractions. So 20. Does it make sense now?
Yeah, it does.
All right. Number 2, y'all mentioned you didn't like the systems of equations on the SAT prep. Well, here we go. System of equations. You have x, y equals 144, and you have that x plus y equals 30. And there's your system. Now, you could try to figure this out the common sense-ish kind of way. You could try factoring the 144. Instead of actually solving the system, being like, well, 1 times 144, that don't add up to 30. 2 and 72, that don't add up to 30. 3 and 48, that don't add up to 30. 4 and 3 times 6, nope, that don't add up to 30. 5 doesn't go in. 6, let's see, 1, 2, and 2 and 4. Hey, that adds up to 30. You could do it that way.
I did that.
And there's really nothing wrong with that, because technically if you solve it the regular way, it's still going to come out to essentially doing that same thing. However, it says, what's the value of x minus y? Well, x has to be the bigger number. Notice it says x is greater than y, which means this is the x, that's the y. So what is x minus y, class? 18. Now, you say, well, what's the algebra way? Well, the way I would have taught you before was to solve by what's called the substitution method. You maybe move the x over as a negative x, and you substitute the 30 minus x in for the y. And you say that x times 30 minus x is equal to 144. You then distribute to get 30x. Negative x squared equals 144, and realize I've got a quadratic equation. Set it equal to 0. Since this is negative, I'm going to make this side to 0. Pull the x squared over as a positive, pull the 30x over as a negative, and leave the 144 a positive. Then you backwards FOIL. And when you do, you get x and x, negative, negative, and guess what you're about to do? Factor the daggone 144 to still get the 6 and 24, right? So you might as well have done it that way. Or there was a shortcut. You could have x squared minus 30x equals negative 144, and you could complete the square. If you were to half the 30 class and square it, 225, you could add the 225 to both sides. That would give you x negative 15 quantity squared when you factor a PST into a binomial squared. This is like all of your algebra class coming back in one nightmarish dream, is equal to, you combine that together and get 81. And then you could take the square root of both sides and get x negative 15, because the square cancel, equals positive negative 9. You could then add the 15 to get 24 and 6.
That's easier?
No, I'm not saying it's easier. I'm saying those are 3 ways to do it. But really, truly, probably the easiest one.
Yeah, that was a fever dream.
All right. So 18 is your answer, letter H. 18 is the answer, letter H. Questions on that? But I did want to show the way you would have learned this in school, the algebra method. But frankly, the common sense, just get it done quickly kind of method, probably better. All right, let's take a look at the next one. Hey, that's this year. This is very now. What's the sign of angle A? Well, sines what over what, class?
Opposite over hypotenuse.
Opposite over hypotenuse. The opposite's 12. The hypotenuse is 13. Letter C, 12 to 13. You better have all gotten that one right.
I got it right.
He's like, yeah, I got it right to change my answer real quick. All right, number 4. This comes from the back half of Algebra 2. which for Jamie was a long time ago. For you guys, it was virtual. And this was when we were in coronavirus and watching on Zoom, but how to come up with combinations of things. Ding's Diner advertises a daily lunch special. Choose one item from each column, only $4.95. Thus, each daily lunch special consists of a salad, a soup, a sandwich, and a drink. How many different daily lunch specials are possible? Well, since there are 3 salads, 2 soups, 5 sandwiches, and 4 drinks, if we multiply the options together, it gives us the total number of combinations, which is 120. Letter J. Did we get that? Does it make sense now? What we did in class a lot of times was if you have so many shirts, so many ties, so many pairs of slacks, how many different outfits, notwithstanding whether or not they match, can you make? Right? You just multiply all the numbers together. Questions on 4. It's been a little while since we did anything with that.
That's kind of weird. $4.95 is kind of a deal with the things that were up there.
I know.
Tenderloin.
A tenderloin, yeah, it's a small tenderloin, right? Like you go to the Dollar Tree and they advertise, we have ribeye steak.
It's like 4 ounces.
No, it's 2 ounces.
Is it really?
Yeah. Actually, it might not have even been 2 ounces. It might not have been 2 ounces. I can't remember. It was really small because I saw ribeye steak on there in the Dollar Tree, you know, there for something totally different, if anything. Oh, ribeye steak, I gotta check it out. It might have been like half an ounce and it was like this thin. Like you couldn't even cook it without making it, you know, rubbery, but like, no, I think I'll pass on the Dollar Tree ribeye steak.
I think it was like a real decent steak.
It didn't look.
Give me your whole stock.
It didn't look like it was good. All right, number 5. The volume V of the right circular cone with radius r and height h shown below can be found using the formula v equals a third pi r squared h. A cone-shaped paper cup has a volume V of 142 cubic centimeters and a height h of 8.5 centimeters. What's the radius to the nearest centimeter of the paper cup? The answer should be letter B, 4. How many got 4?
I got E.
Let's take a look here. So we've got the formula V equals 1/3 pi r squared h, correct? And so the V is the 142. V equals 1/3 pi r squared, and then the h is 8.5, correct? What I'm going to do first is I'm going to get rid of the 1/3 by multiplying both sides by 3. Obviously, when I multiply the 3, it cancels the 1/3. Then I need to divide away the pi, and I need to divide away the 8.5. Or I could put them in parentheses, divide this multiplication in parentheses. I just divide by them individually. But that's r squared. Take the square root. So if you didn't get 4 on your calculator, 3 times 142, divide by pi, then divide the 8.5. Then take the square root of that answer. And it should be approximately 4.
What? Yeah, 15.9.
Did you take the square root yet?
No.
Take the square root of the answer, and you should get approximately 4. You already cleared it out.
Yeah.
Did you get it?
Yes.
Got it? Got it? It's really just calculator work, right? And solving a literal equation or solving a formula for a different variable. So very similar to what we'd be doing in physics. Number, whatever the next one is. That's number 6 on my paper, so I guess that'd be 18 on yours. Boat departs Port Isabel, Texas, traveling to an oil rig. The oil rig is 9 miles east and 12 miles north of the boat's departure point. About how many miles is the oil rig from the departure point? Here, a quick picture would be helpful. Boat, oil rig. Okay? Except it's not drawn to scale because it says you're going to go from boat, you're going to go 9 miles east. I really didn't draw this well. And 12 miles north. 9 east, 12 north. That's where oil rig is. How far do you have to go? What should we do, class? Pythagorean theorem. It's a right triangle.
Oh. Dang it.
And we should get letter H.
81 plus 140.
It's 225. Square root of 225 is 15. Yep, that's all. Pythagorean theorem. Draw a picture. No, draw it better than I do. All right, questions on this? All right, number 7. In that figure, there's equal angles, and there's all these lines, and there's equal lines, blah, blah, blah. Okay, see the picture? Now, it says, what's the length of AD? Notice, if all those angles are equal, what must be true of the little inside triangle and the big outside triangle, class? They must be similar, right? By angle at least, right? Technically angle. But They're similar triangles, and if triangles are similar, sides are proportional. Well, the only sides they make a comparison for us on is this long 20 and a comparative side of 12, right? Okay, so this right here gives you the ratio of similitude 20 to 12, which reduces down to 5 to 3. 5 to 3, that's the ratio of similitude. Then it says that this little piece is 6. And it says, what's the length of AD? Well, notice AD isn't in either triangle, is it? But this line here is line AB, right? So 5 in the big triangle is to 3 in the small triangle, as X in the big triangle is to 6 in the little triangle. How big is this line? 10. Now, it said specifically that AD and BF are equal. If the whole thing is 10, 6 is already here. How much does that leave for both here and here? 4 total, so how much for each? 2. So the answer is 2, letter D. How many have a letter D?
I have, I didn't see.
Does it make sense now? Similar triangles. Sometimes you get lucky guesses, don't you? Questions on that? All right, number 8. Which of the following is a factor of the polynomial 2x squared negative 3x negative 5? You literally factor the polynomial. And when you factor it, backwards FOIL, remember, 2x squared splits into 1x, 2x. Signs are going to alternate. The only way to split up a 5 class, 1 and 5, your outer is a negative 5x, your inner is a positive 2x. Hey, first try. Does it always work that way with backwards FOIL? No, go back in your memory. It's trial and error. So I'm either looking for x plus 1 or a 2x minus 5. Well, that means which letter? H should be our correct answer.
Plus 5.
H. Make sense?
Yeah.
Check those outer
I
inners.
accidentally did that.
Anyone want to practice a backwards FOIL because it's been a while? Or we feel like we're good? You want to practice backwards FOIL? All right, here we go. 3x squared, negative x, negative 14. Find the factors real quick. Maybe do this off to the side. And this is why I say you're not allowed to forget anything, right? Because you're just having flashback after flashback of geometry, of algebra, in some cases pre-algebra, right? These tests assume you remember everything you've learned. So everything you forget lowers that score and lowers the possibilities that are open to you. So my goal now is to help refresh your memory. Bring it back. It's back there somewhere. Bring it back to the front of the brain. So we split up the 3x squared class. 3x and 1x. Signs?
Positive, negative.
Probably want to split that 14 up.
2 and 7.
Probably 2 and 7, right? Outer? Inner? Does that give me a negative 1x? No, change the numbers, right? The number's wrong, change the numbers. So instead of 2 and 7,
7
outer,
negative
negative 6x, inner,
positive
positive 7x. What does that give me? Positive 1x. I want a negative, so now we just change the signs. Remember it now? Again, it's back there. All of this stuff that's on the test is in your brain somewhere. You've learned, well, almost all of this. There'll be a couple things we'll come across here and there. We're like, you haven't actually learned this yet, so in problems that you haven't learned, do your best. But my goal with all of this prep we're doing is just to bring what's in the back of your brain to the front of the brain before you take that test. Number 9. Remember series and sequences. Also learned on Zoom, except for Jamie, just an extra year ago for Jamie, but learned on Zoom during COVID. 1/4 plus x plus 136 plus 108 plus, and it's not so much that you're adding as much as you're finding a pattern. What is the pattern in this? And to give you the hint, it's a geometric series. Do you remember the difference between geometric and arithmetic? Arithmetic adds, geometric multiplies. What gets multiplied from one thing to the next thing to the next thing to the next thing? Well, look right here. What do you multiply by? 3. If you multiply by 3 here, what would that give you?
12.
12 to check. Would a multiplication by 3 give you the next one?
Yes.
Then apparently the number is 12. And, or to be, x is the whole thing, sorry. So x is 1/12, right? So multiplied by a third, technically. 1/12, which is letter C. All right, questions on that? Again, it's just observing a pattern. Number 10. What's the slope of any line parallel to the line 9x plus 4y equals 7? Well, slope. What is slope, class?
Rise over run.
Rise over run. And you might recall something called slope-intercept form. Do you remember y equals mx plus b? The key to figuring out the slope here is to convert this into slope-intercept form. So for this, we're going to move the 9x over to the other side and make it as a 4y equals negative 9x plus 7. Notice we're going to put the x before the constant, and then we can divide everything by 4. And here's my slope-intercept form. The slope of my equation is evidently the coefficient of x, which would be negative 9/4. But it doesn't ask for the slope of the equation. It asks for the slope of a line that's parallel. Do you remember what parallel means in algebra as far as slopes? If lines are parallel, they're going to have the same slope. So if my line has a slope of negative 9/4, the slope of a parallel line will be negative 9/4. And so the answer is letter G. Letter G. Now what if it had asked for the slope of a perpendicular? Do you remember how a perpendicular works? Opposite slope, which means negative reciprocal slope. You'll flip it, make the rise the run the rise, and change its direction. Positive 4/9 would be the slope of a perpendicular line, which wasn't an option here. Okay? You might want to jot that off to the side. Slope of a parallel, same slope. Slope of a perpendicular, negative reciprocal. Because they will ask about slopes on both the ACT and SAT. And they also want to write down y equals mx plus b. Again, this paper is your study guide. That's what it's for, to help you study and prepare for that test. So writing down these notes, very beneficial for you. Number 11, DVD player with a list price of $100, marked down $30. John gets an employee discount of 20%, that's a really good employee discount, 20% off the sale price. How much does John pay for the DVD player? Well, if you get 30% off $100, how much money is that you save? $30. So how much are you paying now? 70. But that's everybody pays 70. Not John. John's special. He gets another 20% off of this. So to find 20% off, we could multiply by 0.2, which would give us $14 off. Right? So everybody was supposed to pay 100 minus the 30% or $30 makes it 70 for everybody else. John gets another 14 off. How much does he spend? $56. How many have letter C? $56.
I had $50.
I had 50. Added. I had 50.
Right, but you see it's not 30% plus 20% is 50% off, but it's 30% off and then 20% off of that new price, not another 20% off the 100. Do we want to do another one like that? All right, so let's suppose we have a $150, what's something that costs you $150 y'all would buy?
Apple TV.
Apple TV costs $150, that's it?
250 actually, but 100.
Okay, let's go with a $150 pair of shoes, because Ethan likes really fancy shoes. Let's suppose that we get, I don't know, they're marked 20% off, and you get a 10%
Friends and family.
customer loyalty discount. Okay, because Ethan is always buying shoes. So they're already 20% off on the website, plus you get an extra 10% loyalty discount because you've bought 17 pairs of shoes in the past 2 years from them. So how much do you pay? Call it when you've got it.
$118.
Nope.
108.
108.
Oh, okay, I see what I did. I did my math wrong. I had the right numbers, I just did the math wrong.
All right. So here's a shortcut, by the way. If you get 20% off, that means you pay 80%, correct? Or 0.8. If you multiply 150 by 0.8, what do you get? $120. That's the sale, right? That's the sale price. But then you get a 10% discount off of this. Well, again, if you get 10% off, what percent do you pay? 90% of the sale price, or multiply by 0.9. And that's where we get $108. Make sense? Now, you could multiply 0.2 and then subtract. You could multiply by 0.1 and then subtract, but it's faster. Hey, you pay 80% if you're getting 20% off. You pay 90% if you get 10% off, right? That's actually something we were just working on in pre-algebra. That's an 8th grade level problem on number 11. Number 12, remembering that I is the square root of -1, how would we represent the value of the square root of -9 squared? Well, mathematically, first thing we have to do is square the -9. Class? 81. So this becomes the square root of -81, right? But remember we said you can't take the square root of a negative. You have to first pull out your I, right? Pull out your negative, right? The square root of -81 is the square root of -1 times the square root of 81. But the way I said it is just pull out your I and get I times the square root of 81. And the square root of 81, of course, is 9. So we get 9i. And there's our answer, letter F.
I remember that now.
Remember pull out your I now? Goes back to Algebra 2. Early second quarter, I think, is where we talked about that, pulling out your I. All right, questions on that? All right, save this paper, put it with the other stuff, use it as a way of review in preparation. By the way, everything on here is stuff you've learned at one point or another, and that's the beauty of the ACT. It's all stuff you actually learned in school. It's just whether or not you remember it. And again, my goal in doing this, to bring it back to the front of your brain. So, hey, maybe you don't do great on this because you're still remembering, but after we go over this, maybe you'll do great on the ACT. And that's the hope. All right, set it aside. Next section in your notes. Next section in your notes. And you did some homework reading over pages 52 to 54. I'm not going to give you a reading quiz over it. But next section in your notes, you want to talk about what you read, and that is trig functions of angles on the Cartesian plane. Did a lot with angles in right triangles specifically, I should say. Did a lot with angles in right triangles, and sine, cosine, tangent, and opposite over hypotenuse and whatnot. But what if the angle's on the Cartesian plane? It's not in a triangle. For instance, you don't have to put this down yet, but let's suppose on the Cartesian plane, we have the point 4, 5. Okay? Now we know if I were to draw an angle in standard position on the Cartesian plane, just looking, not turning, not writing at this point, but if I were to draw an angle in standard position, the vertex would have to be the origin, the initial side would have to be the positive x-axis, and the terminal side, well, that's wherever. In this case, it's got to run through there. So by just drawing a straight line down to the origin, I formed my angle, theta, in standard position, right? But I want to find the trig functions. The sine of theta, when theta goes through 4, 5. The cosine of theta, when it goes through 4, 5. The tangent of theta, when it goes through 4, 5. And of course, reciprocals I could do as well, but for sake of time, we won't. How would I figure this out? Well, sine's whatever what, class? If I got no opposite, no hypotenuse. Let's get one. If I were to draw a straight line down perpendicular, I know exactly how long that line has to be. 5. Whatever the y value of the point is the length of this line, right? I know exactly how long this line has to be, class. 4. It's whatever the x value is. I don't know how long the hypotenuse is. We're going to label the hypotenuse, by the way, r. So to write that down, the hypotenuse, in quotation marks, equals, or it becomes r. R stands for radius vector. Okay, the radius vector, if you will, the radius of the center of the origin to that point, if you will, becomes r. And how would I find the hypotenuse normally, class? Pythagorean theorem. And we're going to find r using the Pythagorean theorem. We're going to take the square root of x squared plus y squared. Since x and y are now legs of this little triangle I drew, by taking the square root of x squared plus y squared, I can get the r value. Make sense? So 4 squared? 5 squared? 16 and 25 adds together to get?
41.
And so we take the square root of that, and that doesn't come out at all. So we'll just say r is the square root of 41. And now guess what we can find? Sine, cosine, tangent. What's the sine of theta, class? What's sine? Opposite over hypotenuse, class.
5 times square root of 41 over 5.
Over 41. Right, opposite y over hypotenuse r, which would be 5 squared of 41 over 41. If you will write this down, sine theta equals y over r. The sine is simply going to equal y, which will be the opposite, over r, the hypotenuse. So how would I find the cosine then, class? Adjacent over hypotenuse, or in this case, what over what? X over r, because the x will always be the adjacent. Now, in terms of the numbers, class, right, 4 over square root of 41, or as you said, 4 square root of 41 over 41. What about the tangent? Tangent's what over what? Opposite over adjacent. Or in this case, class, we could say it is
Y
over x. Which, numerically now, we would say is 5 over 4. Make sure you have this in your notes. Make sure you have this in your notes. Well, and then the hypotenuse is the r. That would be a good thing to have as well. Again, the hypotenuse, that distance to the origin. We use the letter r standing for a radius in a sense. Pretty easy? So, we really still do have a triangle, don't we? So we're not having to reinvent the wheel here. But think about this for just a second. What if I have a point over here? In standard position, there's my vertex at the origin, there's my initial side, and my terminal side is going to go here. There's my angle theta. I can't make a right triangle with theta inside, can I? Because you can't have a right triangle with an obtuse angle, can you? But I can draw what's called a reference triangle that doesn't actually include the theta, but it includes a little angle, rho. This will be my reference angle. Write that down. For angles bigger than 90, use a reference angle, rho. Use a reference angle, rho. We still have x as the adjacent. We still have y as the opposite. We still have r as the hypotenuse. But here's what's interesting. Whatever the sine of rho is, in this case y over r, it will also be the sine of theta. Let's think of an obtuse angle. Call one out. 110 degrees. So let's suppose this is a 110 degree angle. How would I find the reference angle rho? Together, theta and rho complete a 180, right? So how big is rho? 70. Write this down. In quadrant 2, rho equals 180 degrees minus theta. In quadrant 2, rho equals 180 degrees minus theta. Take the sine of 70 degrees on your calculator. Take the sine of 70 degrees. What'd you get?
0.939.
0.93 blah blah blah, right? Take the sine of 110 degrees.